Purchasing aluminum conduit at a discounted price can be worthwhile if specific uses or projects exist. Consider several factors. Firstly, need. Do immediate or future projects require conduit? Secondly, cost. Compare the discounted price to the regular market value to determine if there is a significant savings. Thirdly, specific uses. Aluminum conduit is not suitable for all applications. Consider its limitations and compatibility with intended uses. Aluminum conduit can be used as a riser on a utility pole, providing a pathway for electrical cables. While it is not as strong as galvanized rigid conduit, aluminum conduit can be used as a lightweight and temporary mast for small antennas or equipment. Aluminum conduit can be used for underground laterals to connect to meter sockets, potentially eliminating the need for expansion fittings. Aluminum conduit is susceptible to corrosion in certain soil conditions. Supplementary protection is required to prevent degradation. Enclosing the conduit in a non-metallic covering or applying a protective coating are common supplementary protection methods. Burial depth is also important to minimize potential damage from soil conditions and physical stresses. Aluminum conduit at a discounted price can provide cost savings. Aluminum conduit is generally strong and durable. It can be used for various applications, including risers, laterals, and masts. However, it requires supplementary protection for underground use due to corrosion susceptibility. It may not be suitable for heavy-duty applications. Aluminum conduit is not generally suitable for high-power or grounding applications due to limited electrical conductivity. If a specific need for aluminum conduit exists and the discounted price is attractive, it can be worthwhile to purchase the surplus material. However, it is crucial to consider the limitations of aluminum conduit and ensure proper supplementary protection for underground use. Where aluminum conduit is installed underground, it requires supplementary protection to prevent corrosion. This protection typically involves one or more methods to isolate the aluminum from direct contact with the soil and its corrosive elements. Firstly, consider coating. Applying a protective coating to the aluminum conduit is a common practice. These coatings are typically non-metallic and designed to resist moisture, chemicals, and other corrosive agents found in the soil. Epoxy coatings, polyurethane coatings, and specialized paints formulated for underground use are examples. The coating should be applied evenly and completely, ensuring that all surfaces of the conduit are covered, especially at joints and fittings where corrosion is more likely to occur. Secondly, consider wrapping. Wrapping the aluminum conduit with a non-metallic tape or sleeve is another effective method of supplementary protection. The tape or sleeve acts as a barrier, preventing direct contact between the conduit and the soil. Materials such as polyethylene, PVC, or specialized corrosion-resistant tapes are often used. The wrapping should be applied tightly and with sufficient overlap to ensure complete coverage. It is essential to select a tape or sleeve that is compatible with the soil conditions and the aluminum conduit itself. Thirdly, encasement. Encasing the aluminum conduit in concrete or another non-corrosive material provides a robust form of supplementary protection. This method is particularly effective in highly corrosive environments or where the conduit is subject to physical stress. The encasement material should completely surround the conduit, providing a barrier against moisture, chemicals, and physical damage. Concrete encasement also offers additional mechanical protection, which can be beneficial in areas with heavy traffic or potential for excavation. Fourthly, consider the use of a sand bed. Installing the aluminum conduit in a bed of sand can provide a degree of supplementary protection. The sand acts as a buffer between the conduit and the native soil, reducing direct contact with corrosive elements. The sand should be clean and free of organic matter or other contaminants that could promote corrosion. This method is often used in conjunction with other forms of protection, such as coatings or wrappers, to provide a multi-layered approach to corrosion prevention. Fifthly, proper burial depth. Ensuring that the aluminum conduit is buried at an appropriate depth can also help to minimize corrosion. Deeper burial depths can reduce temperature fluctuations and exposure to surface contaminants, which can contribute to corrosion. Local codes and regulations typically specify minimum burial depths for electrical conduits, and these should be followed carefully. In addition to depth, the backfilling material should be carefully selected to avoid damaging the conduit during installation. Finally, consider cathodic protection. While less common for residential or small commercial installations, cathodic protection is a highly effective method of preventing corrosion in underground metallic structures, including aluminum conduit. Cathodic protection involves applying a small electrical current to the conduit, which counteracts the natural electrochemical processes that cause corrosion. This can be achieved through the use of sacrificial anodes or impressed current systems. Cathodic protection is typically used in more demanding applications, such as pipelines or large industrial facilities, but it can also be applied to smaller conduit systems where corrosion is a significant concern. Proper installation and maintenance are crucial for cathodic protection systems to function effectively. The National Electrical Code, or NEC, provides guidelines for the installation of electrical conduits, including those made of aluminum. While the NEC does not specify the exact methods of supplementary protection required for underground aluminum conduit, it does emphasize the need to protect electrical equipment and wiring from corrosion. NEC Section 300.6 addresses protection against corrosion and deterioration, stating that raceways, cable trays, cable bus, auxiliary gutters, cabinets, equipment cases, and other electrical equipment must be suitably protected against corrosion. This section requires that materials used in corrosive environments be approved for the specific conditions. For underground installations, this typically means using listed or labeled conduits and fittings that are specifically designed for direct burial. The NEC also provides requirements for minimum burial depths for electrical conduits in Table 300.5. These depths vary depending on the type of conduit, the voltage of the circuit, and the location of the installation. Following these requirements is essential to protect the conduit from physical damage and minimize the risk of corrosion. In addition to the general requirements for corrosion protection, the NEC also addresses the grounding and bonding of electrical systems. Proper grounding and bonding are essential for safety and can also help to reduce the risk of corrosion. Aluminum conduit can be used as an equipment grounding conductor, but it must be installed in accordance with the NEC requirements. Section 250.118 lists the types of equipment grounding conductors that are permitted, including metal raceways such as aluminum conduit. However, it is important to ensure that the conduit is properly connected to the grounding system and that all fittings and joints are tight and corrosion resistant. When installing aluminum conduit underground, it is also important to consider the potential for galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in electrical contact in the presence of an electrolyte, such as soil. The more active metal corrodes preferentially, while the less active metal is protected. Aluminum is more active than many other metals commonly used in electrical systems, such as steel and copper. Therefore, if aluminum conduit is in direct contact with these metals in the soil, it may corrode more rapidly. To prevent galvanic corrosion, it is important to isolate the aluminum conduit from dissimilar metals. This can be achieved by using insulating fittings or connectors, or by coating the dissimilar metals with a protective coating. It is also important to ensure that the grounding system is properly designed to minimize the flow of current through the aluminum conduit. The choice of supplementary protection methods for underground aluminum conduit depends on a variety of factors, including the soil conditions, the depth of burial, the type of electrical system, and the local codes and regulations. In some cases, a single method of protection may be sufficient, while in other cases, a combination of methods may be required. It is always a good idea to consult with a qualified electrical engineer or contractor to determine the most appropriate protection strategy for a specific installation. Proper installation and maintenance are also essential for ensuring the long-term performance of underground aluminum conduit. The conduit should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. The backfilling material should be carefully selected to avoid damaging the conduit, and the soil should be properly compacted to provide support. Regular inspection should be conducted to check for signs of corrosion or damage, and any necessary repairs should be made promptly. By following these guidelines, it is possible to use aluminum conduit safely and effectively in underground electrical installations. Remember, the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or contractor before undertaking any electrical work. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for anyone involved in electrical work to be familiar with the NEC and to follow its requirements carefully. Aluminum conduit is addressed in several sections of the NEC. Article 344 covers rigid metal conduit, or RMC, which includes both steel and aluminum conduit. This article specifies the requirements for the installation, support, and grounding of RMC. It also includes provisions for the use of RMC in corrosive environments. Section 300.6 of the NEC, as previously mentioned, addresses protection against corrosion and deterioration. This section requires that raceways, cable trays, cable bus, auxiliary gutters, cabinets, equipment cases, and other electrical equipment must be suitably protected against corrosion. This requirement applies to all types of conduit, including aluminum conduit. Table 300.5 of the NEC specifies the minimum burial depths for electrical conduits. These depths vary depending on the type of conduit, the voltage of the circuit, and the location of the installation. It is essential to follow these requirements to protect the conduit from physical damage and minimize the risk of corrosion. Article 250 of the NEC covers grounding and bonding. This article specifies the requirements for grounding electrical systems and equipment. Aluminum conduit can be used as an equipment grounding conductor, but it must be installed in accordance with the NEC requirements. Section 250.118 lists the types of equipment grounding conductors that are permitted, including metal raceways such as aluminum conduit. It is important to ensure that the conduit is properly connected to the grounding system and that all fittings and joints are tight and corrosion resistant. When installing aluminum conduit underground, it is also important to consider the potential for galvanic corrosion. The NEC does not specifically address galvanic corrosion, but it does require that electrical systems be installed in a manner that minimizes the risk of corrosion. To prevent galvanic corrosion, it is important to isolate the aluminum conduit from dissimilar metals. This can be achieved by using insulating fittings or connectors, or by coating the dissimilar metals with a protective coating. It is also important to ensure that the grounded system is properly designed to minimize the flow of current through the aluminum conduit. The NEC also includes requirements for the use of listed or labeled equipment. This means that electrical equipment, including conduit, must be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listed or labeled equipment has been found to meet certain safety standards and is suitable for its intended use. When purchasing aluminum conduit, it is important to look for the UL listing mark to ensure that it meets the NEC requirements. In addition to the NEC, local codes and regulations may also apply to the installation of aluminum conduit. These codes and regulations may be more stringent than the NEC requirements, so it is important to check with the local authorities before undertaking any electrical work. Local codes and regulations may also specify the types of supplementary protection that are required for underground aluminum conduit. They might also specify that an electrical inspection is to be performed after the work is done to make sure everything is up to code. It is imperative to follow all codes and regulations to ensure safety. Aluminum conduit offers several advantages over other types of conduit, such as steel and PVC. Aluminum is lightweight, corrosion resistant, and easy to install. It is also non-magnetic, which can be an advantage in certain applications. However, aluminum conduit also has some disadvantages. It is more expensive than steel conduit and it is not as strong. It is also susceptible to galvanic corrosion if it is in contact with dissimilar metals. When deciding whether to use aluminum conduit, it is important to consider the advantages and disadvantages in relation to the specific application. In some cases, aluminum conduit may be the best choice, while in other cases, another type of conduit may be more appropriate.